Okay, so it's the quiz question, and it says volume varies inversely. Did you notice that word inversely? That's key, huh? Inversely with pressure, P. So then basically they say volume is 250 when pressure is 21, and what is volume when pressure is 35? That's basically what that's saying, although there's nothing on the screen. Technology. Here we go. All right, so what do you do when it says inversely? Side by side, right? Side by side. So 250, this will come up in a minute here, is V times 35. Or you call it X or whatever you want. Does that make sense? On that, you put them side by side. If it says varies directly, that's two equal fractions, isn't it? So that's on today's test, right? It says varies directly, two equal fractions. If it says varies inversely, two side by sides, right? And this one says inversely. So it's two side by sides. You would get answer D if you accidentally made them two fractions. That's how you would get D. So I'm talking to that one person again, whomever that may be, blasting them or whatever. All right, sorry, I'm having fun with that phrase. All right, 250 times 21, what is that? 5,250. And V times 35, solve for V, last step. Divide by 35. V equals, I have no idea. Well, it's got to be that answer, 150. Just looking at it was answer C, 150. Is that good? So inversely, side by side, directly, two equal fractions. Don't mix that up, or you'll be on blast. Or I'm probably misusing the saying now. Anyway, whatever. Good? Questions on that? All right. We got a big agenda today. It's just 7.3, but we got to do it because we have exam 4. As you know, the big and the bad. Sounds kind of funny. It is. Because 7.3, 7.2, and 7.1 are all covering the same topic, how to solve two equations at the same time, two equations with two letters. But 7.3 is the best way. So I want to do it first, do it slow. I'll spend like an hour and a half just on this one section. I'll do almost every problem to where you're really good at this one technique. And then tomorrow, when we get to the other techniques, I'll say, hey, just do it the first way if you want. You know, I'll hardly teach the new techniques. And I'll just say, hey, look, you can just do them all the way we learned today, and it'll be great. And just do that all the time. So that's why I'm going backwards, and while we'll go slow on 7.3. You get this down, and you can do the other ones fine. I'll mention the other techniques, but I'll say, this is the best one. Just do it this way. Okay, so here we go. How do you solve two equations at the same time? Two of them at the same time. Yeah.
You could just take out the line.
Yeah, exactly right. Yeah, we're going to add them. Yeah, but you're right, and the y's are going to be taken out. Exactly right. Yeah, you just add them straight up and down. Have you seen that before? Sounds like some of you have, at least one of you. Seen that before? You just add straight up and down. That's right. Yeah, this method that we're doing right now, it's called the elimination method. It's also called the addition method. It goes by both names because you add them up, and when you do, things eliminate. So here we go. So let's add the x's straight up and down. I'm just adding straight up and down, column by column. So x plus x, what's that going to do? Is it x squared? No. It's not. It's 2x, huh? Why not? When do you get x squared? Multiplying. Yeah, if we were multiplying, it would be 2x. I'm sorry, it'd be x squared, but we're adding, so it's 2x. It's 1x and 1x is 2x. We're just adding, right? Okay, what happens with the y's? What is the positive y and the negative y? What do? They cancel out. They make 0, huh? So they're gone. That's the elimination thing. They eliminate, don't they? And then the numbers, 9 minus 7, 2. Now that's great. Why is that great? Well, it's great that one of the letters eliminated went away because we can't really solve two letters at the same time. We need to get somebody to drop out. Now, somebody has, y's dropped out. Now we can solve for x. That's a simple equation. What do I do to solve for x?
Divide by 2.
Just divide by that 2, right? And x is 1. So we got x, but we do have to get y also. Even though it dropped out, we can go back and get it. So we've got x. X is 1. We need an answer for x and for y. How do we get the x? I mean, we have the x. How do we get the y answer? Plug it in, yeah. Just come back up here. Say plug in x is 1. Where do we plug in? It doesn't matter. Anywhere you want, really. Any of those equations. I'll just grab the first one, but you could totally do the second one, and it would work just fine. I'll just grab the first one. Plug in x is 1. 1 plus y is minus 7. How do we solve for y? Subtract 1 from both sides. Y is minus 8. So we get an answer for x. X is 1. Got an answer for y. Y is minus 8. So the overall answer, how you give the overall answer is you have to put parentheses with a comma, the x first, and then the y. There's the overall answer. They want what's called, that's called ordered pair. See how they say here, ordered pair? That means two numbers with a comma and parentheses. And it's got to be in the right order, meaning x has got to be first and y has got to be second. There we go. Now what are those two numbers? Those are the numbers that make the thing true, aren't they? If I put in 1 for x and both places, and negative 8, right? Yeah, negative 8 for y in both places, did you know it'll make both equations true? Right, everybody see that? 1 plus negative 8, yeah, that's negative 7, huh? And 1 minus a minus 8. What's minus minus? Plus 8, 1 plus 8, 9, yeah. See how it's working? See how it's making both equations true? So 1 for x, negative 8 for y are the plug-ins that make both equations true. That's the answer, in other words. It's the answer to both equations, so we say it's the answer to the whole system. Make sense? Easy enough on that? That good? Are you happy about that? There you go. All right, we'll move on. So number 2. X plus y is 14. 4x minus y is at 16. Yeah, 16. All right, can you do the same thing on that one? Can you just add them straight up and down? Just add them straight up and down. The y's will eliminate. All good, so we add them up. X and 4x, that's really 1x and 4x, huh? So 5x, the y's eliminate. What's that, 30? So 5x equals 30. Then how do we finish? We just divide by the 5, like so. So x is x. So we got an answer for x. Not check. We're checking. We're plugging in. So then you get that answer for x, and then now take that and plug it in, huh? So take the first equation. You could do the second. Doesn't really matter. And plug it in. So take that 6 and put it right in there. 6 plus y is 14. Last step, subtract 6. Y is 8. So we got our answer. What's our answer? It is 6, 8 with parentheses, right? You got to put the x first, then the y. Ordered pair, the order matters. X first, then y. Comma and parentheses. You can check it if you want. You put x6, y8, x6, y8. It should make both true. So you could grade your own test for this next test, right? At least these parts. You would know whether they're true or false, right? You know whether your answer is right. Let's see it. 6 plus 8, 14, yeah? 4 times 6? 24 minus 8, yeah, 16. Makes them both true, doesn't it? So that's the real answer. Are we good? That's pretty easy. You seen this kind of thing before? Just add them up and the y's eliminate. All right, let's change gears. Okay, so 4x plus 3y is 8. 8x minus 3y. 8x minus 3y is minus 56. Yeah. Okay, same thing. Try adding those vertically straight up and down. So the y's should eliminate again. So add them up. 8x and 4x, 12x. Y's eliminate. Is that minus 48? So x is going to be negative 4, right? X negative 4. There we go. So now let's plug in x is negative 4. How do we plug it in? We grab that first equation. And we plug in the negative 4 right there. Is that good? Plug in that negative 4. What do we got? Negative 16 plus 3y is 8. So here's y is saying I want to be alone, right? We're good here, so just add the 16 to both sides. And so then we get what? 3y is 24. 3y is 24. I'll bring it up here. So 3y is 24 divided by 3. Y is 8. So we got x negative 4, y 8. Is that working for y'all? X negative 4, y 8. Got to put x first, then y. Parentheses, comma. There we go. Is that good? Questions I can answer for that. See how that's working? We just add them up and the y's eliminate. Now, they've been making it nice. They're going to be not so nice after this. Have you noticed that they're always making the y's just be the same exact number, one positive, one negative, in other words, opposites, so that they cancel when we add them. They've been giving us that. Right? They've been making it that way. Well, they're going to change that up now. Thank you. So they're going to change that up so it isn't that way. So, and we're going to have to make it that way ourselves. Does that make sense? Like if these guys were not already the same number, one positive, one negative, opposites, then I would have to make them that way before I add. Or it wouldn't work. Because I need y to drop out. I can't have both letters. I can't solve with both letters still in there. I need one of the letters. I need y to eliminate. Then I can solve for x. That makes sense? So if they haven't already made it nice, you got to make it nice. So here's what I mean. Let's look. So it's x plus y is negative 9, and 4x plus y is negative 33. Yeah. See how, don't write this down. Write that down, but I'm about to do something that won't work. So don't do what I'm about to do. I just want to show you that it won't work. It's helpful to see it, but you don't want to do it. So if I was to add right now, it won't work. It won't work right now. If I add right now, I'll get 5x. And will these guys eliminate? No. They'll make 2y. And this will be, I don't know what, 42. See, that didn't work. The y's did not eliminate because they're both positive y, aren't they? You got to have one be positive y and one be negative y, don't you? So they eliminate. Am I making any sense? Am I doing the Charlie Brown teacher right now? Or am I making sense? Do you see what I'm saying there? You got to have positive and negative. Well, it's kind of a big mess now. I just scribbled it all up. What was it? It was x plus y, 4x plus y equals, oh, this is all messed up too. Anyway. Equals, minus, right? Yeah. Anyway, there's the original problem. Yeah. So, right? So it's not good right now. See, let's go back over. See how we had plus 3y and minus y? That was good. They were opposites. Here we had plus y and minus y. So they eliminate. You got to have one positive, one negative, the same number to get them to eliminate. So I've got to make like maybe that one negative y or the bottom one. It doesn't matter which one. Just make one of them become a negative y. Then add after that, and the y's will eliminate. Does that make sense? Got to make one of them negative. So how do I make one of them negative? How do you do that? Yeah. Just multiply negative 1 through the top equation before you add. Does that make sense? This time I have to tinker with the top equation. I have to mess with the top equation before I add. Because if I just add right now, the y's will not eliminate. Right? You got to have one positive, one negative for them to eliminate. So multiply through the top equation by negative 1. What happens then? Well, then we get negative x minus y, and that's going to be plus 9, huh? Yeah. The bottom equation didn't change at all. I just brought it down to keep things kind of orderly, you know. Is that better? So now see how the y's, well, now they're opposites, huh? Does that make sense? Now's the time to add. So now, go ahead. Can you finish it from there? Now that we did that, now that we made the y's opposites, now we can go ahead and add them up, and the y's will eliminate. So 4x minus 1x is 3x. We good? And minus y and plus y drop out, right? Over there, that's, I don't know, what is that? 24? Minus 24? We good? Everybody see how that made it eliminate? Does that make sense? That made the y's eliminate. I made the y's opposites. 1 plus, 1 minus, huh? Is that good? So the y has dropped out, which is excellent. That's what we want. Now we can solve for x. So just divide by 3. X is minus 8, like that. So we got our x. Plug in. X is minus 8. Where are we going to plug it in? Top equation. plug in x is minus 8 there. How do you finish getting y alone? Add the 8, right? Add the 8 to both sides. Y is, what is that? Negative 1. So we got our answer. Negative 8 for x, negative 1 for y. There's x, y. We are done. So is this making sense, y'all? Is this good? Right, so we got to make the y's be opposites before we add. In the beginning, they were not opposites. They were the same. I had to multiply through by negative 1, the top equation, to make these guys opposites. I didn't mess with the second equation at all. I just multiplied the top by negative 1 to make these opposites. And then I added, and the y's eliminated. See why we make them opposites? Because we want them to drop out, right?
Couldn't we subtract the two equations and still get the same answer?
You could on this one, yeah. I wouldn't suggest that. I mean, this one is fine. Other ones it's going to be messy. You'll get messed up with your signs. But do what you want. But yeah, you technically, yes, that will work. Mm-hmm. Good on that. So 8x minus y is 22. X plus 3y is 9. So look at the y's. They're not opposites, huh? They're not opposites. So you've got to make them opposites. The top one is a negative 1y, huh? What do we got to make that top y become so these guys will be opposites? 3, yeah. So take that top equation, multiply through by 3. Does that make sense? You got to make that y negative 3y, don't you? So, well, not 3, not multiply by regular 3. It's already got the minus. So multiply the top equation by 3, 3, 3, 3, and then that top equation will become minus 3y. Good, and then the y's eliminate. Big X comes out 3, doesn't it? So if you add those up, 24x and 1x is 25x. The y's eliminate. 75. Last step to get y alone. Divide through by 25. X is 3. Good, we got x. X is 3. Bring it on up here. Plug in x is 3. Where do you plug it in? You know, you can plug into any of those equations, by the way. Any of them. It doesn't matter. First one, second one, third one, fourth one. Any of them, it'll all work the same for any of them. I just always grab the first one, but any of them would be fine. Put in the 3. 24 minus y is 22. Can you just solve by observation. You know what I mean? You just look at it. 24 minus what is 22? 24 minus what is 22? 2. Y's got to be 2. If you can see that, just stop. Y is 2. But you can go through the formalities. I know it's probably not what you normally do is try to stop and guess, but save you some time. But I'll go through the formalities. Subtract 24 from both sides, right? And then that gives us minus y is minus 2. Last step to get y alone, got to get rid of that minus sign. So what do we always do? Divide by negative 1. Boom. Negative 2 over negative 1. 2 negatives. Positive 2, as we already observed. Y is 2. So the answer to the question is x is 3, y is 2. X first, then y. There we go. So how are we doing? Is this making sense? They're about to make it a little messier. Are you good to this level? Does everybody see what we're doing there? We're making the y's become opposites, right? So that when we add them up, the y's eliminate. We good? Okay. So I'm going to go on if you're good with that. It's all about making the y's be opposites. Skip some, but they all have a good little lesson. All right, so try this one. It's going to be x minus y is minus 9. 7x minus 9y is minus 71. There we go. So make those y's opposites. Make those y's opposites. So right now it's a minus 1y. So what are you gonna multiply that top equation by to make what do you want to make that top y? You want to make it into a positive 9, right? Because that's the opposite of the minus 9y. So what do you got to multiply the negative 1 that's currently there by to make that positive 9y? Got to multiply by negative 9. Is everybody seeing that? Yeah.
What if you just do the x's?
You totally could. Totally could. If you already know about that, feel free to do the x's and make that a negative 7x. Yep. That'd work just as well. Yep. It doesn't have to be y. So I'm just gonna stick with y for now. So I'm gonna multiply through by negative 9. Right, everybody tracking with me on that? That'll make positive 9y in the top middle, won't it? So that's the opposite, and the y's will eliminate when you add. So good for the top one and the bottom one, we just bring it down, no changes. All good. Now add them up. The y's will eliminate. I think you get x minus 5, is that what it is? Negative 5 for x. Plug that in for y. All right, we get that, so minus 2x, and that's positive 10. All right, the y's eliminate. Finish solving there for x. Divide by minus 2. X is minus 5. Good. So there's our x answer. And now bring it up here. Plug in x is minus 5. Where do we plug that in? You grab the first equation. Bring that down. X minus y is minus 9. So like I said, you can plug it into any of these. You can plug it into the ones before you multiplied, after you multiplied, doesn't matter. It'll work for any of them. So grab the x is negative 5 and put it in. Like that. And then add 5 to both sides, trying to get y alone here. So negative y is negative 4. Last step to get x alone, divide by negative 1. Y is positive 4, regular 4, isn't it? Good. So the answer is, what was x? There it is. X was negative 5. Y is positive 4. Negative 5, positive 4. X, comma, y. X, comma, y. Negative 5, comma, positive 4. How are we doing? They're going to make it a little messier. Are we good to there? Is this making sense? It's all about making the y's become opposites. Same number, one positive, one negative. Okay, if I move on. All right. So 7x. I'm going to make it x and y, even though the problem says R and S. My S's look like 5s, so I don't want to do that. Here, actually, let me scoot it over a little bit. So 7x minus 8y is minus 15. 8x plus 7y is 112. Okay. So the deal is now, on this one, same game, right? We're trying to make these y's become opposites. I want to make those y's become opposites. So this one's a little harder. What are we going to do to make those y's become opposites? Same number, but one positive, one negative.
Multiply by 8 and 7.
Multiply by what? 8 and 7? Yeah. Multiply by the other one, huh? Exactly. Just multiply by the other one, right? If I take the 8 up here, multiply by 7, the other one, and down here the 7, I multiply by 8, that'll make them both the same thing, because they'll both be 8 times 7, they'll both be 56. Right? Does that make sense? So you just multiply by... So basically, you see the difference? If both of the y's have a number, just multiply by the opposite guy, versus back over here, if only one of the y... I mean, if one of them has a 1, basically, just multiply by the other guy. So if one of them has a 1, you just multiply by the other guy. But if neither of them have one, if they both have different numbers than 1, then just multiply by the opposite guy. That'll do it. Exactly right. So let's multiply through the top one by 7, and then the bottom one by 8. See how that'll make both the y's into 56. See that? Both the y's will become 56. One will be a negative 56y. The other will be positive 56y. All right, let's see what we got. 49x minus 56y, and 7 times 15, what's that? 73. Minus 105. 64x plus 56y. 88 and is it 896?
Yeah.
Thank you. Is that good to there? See what I did? Do you all see? See how the y's are opposites now? Same number, one positive, one negative. So now you can add them up, huh? And the y's will eliminate. So if the y's both have numbers, you multiply by the other guy. Take it from there. So add them up. 113x, the y's drop out. Was that 791? Yeah. Just bring it up here, 113x. There's 791. Last step is divide by that 113. X equals, it was just 7, huh? Isn't that nice when the answer comes out clean like that? All that big mess, and you're like, 7. Yes. There's 1. There's the. I'll show it to you. It's like almost the second to last problem is awful, and the answers come out like that, but it doesn't reduce. It just stays like yucky terrible. Yeah, there's 1. I'll show it to you at the end. Yeah, so this one's nice. When you get that, you're like, something good's happening here. To get my master's degree at Cal Poly, I had to take a really, really hard test. No big surprise there. And they made a rule. They started it the year I was in the master's program. It was a new rule that basically this big test, you could take it, and if you failed it you could retake it and suspend. They change it, and anyway, it's offered every 3 months on a Saturday for 2 hours, a real special deal. Anyway, it's called an entrance exam for the master's program in math. Anyway, if you failed it twice, you could never get a master's degree in math at Cal Poly. That was their new rule. Like you can't come back next year. Yeah, not at Cal Poly. They would never grant you a master's degree in math for the rest of your life. Yeah, 2 shots, that's it. If you fail it twice, they don't want you.
You'd have to transfer out.
You have to get a master's somewhere else. But notice you can't wait there and say, oh, well, I'll come back in 5 years. And no, you've done it twice. Go away. You know, that's their plan. That was their new rule, that 2 shots. Because they had a bunch of people retaking it, and they felt like they weren't quality, and so they just made that new rule. 2 shots, bye-bye. Well, I failed it the first time. So I failed it the first time, and so I had 1 more shot, or it was bye-bye. You know, so I studied for 3 months. They offered it every 3 months on a Saturday in the math science building, this big 2-hour exam. Anyway, so I studied for 3 months. Again, I'd already studied for the first 3 months, you know. And anyway, I took this exam. I was in the middle of the exam, and, you know, it wasn't quite like this. It was different stuff. But anyway, my numbers were, like, coming out clean. I was like, yes, something good is happening. That's got to be right. That can't be a coincidence. I'm going to graduate. It was a very good feeling. So it's nice when the numbers come out clean like that. You're thinking, I'm on track. Something good's happening here. All right, so we have X. Now plug it in for Y, right? Plug it in. So plug in X is 7. So where do you plug in? Anywhere you want. I'm just going to grab the first equation. 7x minus 8y is minus 15. Take that 7, plug it in. 7 times 7 minus 8y is minus 15. Good to there. I plugged in the 7. Okay, I'm totally running out of room here. Bring it up here. What do we got? 7 times 7, 49. 49 minus 8y is minus 15, right? So got to solve for y there. So subtract 49 from both sides. Minus 8y is something. 64. And then divide by minus 8. 2 negatives, positive 8. There it is. 7, 8. After all that work. XY, 7, 8. We got it. Is that okay? Is that making sense? Do you all see how to do that? So again, you've got to make the y's opposites, right? 1 positive, 1 negative, same number. How do you do that? If they both have numbers, you multiply by the other guy, right? The y's drop out, you get x, plug it in, you get y. Questions I can answer on that one? Okay? All right, I'm going to move on if you're okay. 3x minus 8y is minus 52. 8x plus 3y is 56. All right, same kind of thing. Got to make those y's be opposites, right? Got to make those y's be opposites. So multiply by the other guy, right? Multiply top equation by 3, bottom by 8. So they're both going to become 24, right? Multiply by the other guy, both going to be 24. One's going to be a negative 24y, one's a positive 24y. Is that 448? Yeah. Add them up. Y's eliminate. 73x is some big number. 292. Thank you. So 73x. Y'all getting to there? There and beyond? So I'm hoping that when I divide by 73, I'm going to get something nice and clean. Is it just 4?
Yes.
That's when you know you're on the right track, right? It's like, yeah, I've got to be doing something right. That's a clean answer. 4. So we got x. Now plug in for y. So plug in x equals 4. So let me grab it. I'll just grab the first equation as I always do. 3x minus 8y is minus 52. And then plug that in for x. So I'm going to bring it up here. I'm running out of room. 3 times 4 minus 8y is minus 52, yeah. So that's 12 minus 8y is minus 52. Good. Finish solving for y there. Subtract 12 from both sides. Minus 8y is minus 64. Divide by minus 8. It's almost like what happened last time, isn't it? So y equals positive 8. The two negatives make positive. So what are the answers? X, where was x? Oh, here, 4. So the answers are 4 for x and 8 for y. There's x, there's y. 4, 8. Boom. Are we good? X is 4, y is 8. Getting the hang of these? Questions I can answer? All right. Then they'll do a couple crazy things at the end. But you've really seen the basics of it now. So x equals 5y. 3x plus 14 is regular y. Okay, so two equations. They got things kind of moved around a little bit. It's actually fine to leave it like it is because as long as they're lined up with each other, and they are. X's are on top of X's. Numbers, you can put a 0. If it bugs you, you can put a 0 there, whatever. You don't have to. Numbers over numbers and Y's over Y's. X's over X's, numbers over numbers, Y's over Y's. So, yeah, it's good enough. We don't need to, you don't have to move anything around. Now, if they were not like X's over X's and Y's over Y's and numbers over, then you'd have to move things around. But we're okay with it like this. Okay, so now, as has been mentioned, we've been eliminating y, huh? We've been making the y's become opposites. And you can just always do that if you want. Or you can do the x's. It doesn't matter. Basically, you just need one of the letters to go away. Because you can't solve both of them at the same time. You got to have one letter eliminate so you can solve for the other one. So how about we do x this time? How about we just make the x's become opposites, and then that'll go away, and we'll do it that way this time. So what can I make? What do I make that top x? Only one of them. Notice only one of them has a number. Let me look back, make sure it's making sense. On the last problem, both the y's had numbers. So if they both, I mean, other than one, right? If they both have numbers other than one, you got to multiply by the opposite guy to make them the same, right? But if only one of them has a number, and then the other one has a 1, what do? Just multiply by that other number, huh? But you got to make it negative 3x, don't you? Because you got to make it opposite. So what are we going to do? We're going to multiply that top equation by negative 3, right? It's all good. It's all making sense. How to make that a negative 3x, opposite of positive 3x. Is that good? So we'll eliminate x. So go ahead and take it from there. It'll be just regular from there. Is that? Did everybody see how I decided that? You've got to make somebody opposites. Either x or y, doesn't matter. I decided to make x's opposite. So multiply by negative 3, and those x's will be opposites, won't they? So if both the x's or y's or whatever have numbers, you do the opposite number. If one of them, only one of them has a number, you just do that one. So I don't have to multiply the bottom equation by anything on this one. It's good to go. Right? So I'll get negative 3x plus 0. Anything times 0 is 0. We're multiplying, right? Is negative 15y. The bottom equation is like that. There we go. Now we can add them up, and the x's will go away for us, which is nice. Okay, so add them up. X is canceled. Bye-bye. 14. This is minus 15y plus 1y is minus 14y. Right? 1 minus 15 is minus 14. Very good there. X dropped out. Eliminated. That's what we wanted. So that's good. How do we solve for y? Y saying I want to be alone. So divide by minus 14. So y is negative 1. So we got y. Negative 1. So now plug in for x. Same thing as regular from here, right? So bring it over here. Plug in. Y is negative 1. Where do you plug in? First equation. I always just grab the first equation. Grab the first one. X plus 0, or just nothing, is 5y. So plug in negative 1 right there. X is 5 times negative 1. X is minus 5. So we got our answer. It is x negative 5, y negative 1. It's always x first, then y. And there we go. Negative 5 comma negative 1, x comma y. Am I going too fast? Is that okay? Questions I can answer? So what did we do? We just made the x's opposites instead of the y's. Works the same. Doesn't matter. You just got to get one of the letters to eliminate. You can solve for the other one. No questions? All right, I'll move onward and upward. A wrinkle. So 2x minus 3y is 33. 3x plus 6y is negative 3. Okay. So we could do the x's or the y's, you know, doesn't really matter. Got to make them opposites. So, well, let's do the y's, how about? How about we do the y's? So, what are we going to do? Yeah, does everybody see that? I mean, I said, I'm kind of changing my plan. I want you to see that. What I've said so far is, hey, if they both have numbers, like, you know, both the y's have numbers other than one, then multiply by the other guy. You could do that. That'd work. But it'd be easier. Do y'all see that it would be easier to just multiply the top equation by 2, right? 2 times negative 3 would make that negative 6, huh? So really, the name of the game is make the y's be the same number. One positive, one negative, opposites, so they'll eliminate, cancel when you add them. Do that however you can do that. It doesn't really matter how you do it. Just somehow or other make the y's, or you can do the x's. You can make both those x's into 6. One of them a negative 6, the other positive 6. Either way, it'll work either way. So I'll just do the y's, I guess. So I just wanted to show you that sometimes you can do something easier. See, that's easier, huh? Just multiply that top by 2, make that negative 6y up there. Don't even need to mess with the bottom one. So you all see what I'm saying on that? It's just do whatever it takes to make the y's opposites. And there's lots of ways to do that. So top equation, bottom equation. We good there like that? See how the y's are opposites now? And then add them up. 7x, the y's cancel, 63. Good? This easy? I can't tell if this is like boring for you and so easy, or if it's hard for you and you're barely following me. You guys just have a good poker face. X is 9. X is 9. Good? I don't know if you're bluffing or you're really betting. If you got the cards or you really don't have the cards. All right, so X is 9. Now plug it in for Y. Go get Y. So 2x, oops, kind of running out of room here. So 2x minus 3y is 33. Plug in x. 2 times 9 minus 3y is 33. 18 minus 3y is 33. Good to there. Okay, so we got to solve for y. Y is saying I want to be alone. So subtract 18 from both sides. So minus 3y, what's that? 15? Right, did I do that right? Yeah. And then the divide by negative 3. y is minus 5. So the answer is 9, comma, minus 5. That's xy. Good? We good there? All right, I'm going to move on. I'm going to assume you've got the cards and you're good. Okay, so 5x minus 4y, oops, getting a little scribbly there, plus 3 minus 10x plus 8y is minus 6. Yeah. Okay. So go ahead and let me let you do that. You'll see something weird will happen. You can do the x's or do the y's. It doesn't matter. You know, make them opposites. So what do we got to do to make the y's opposites? What do we got to multiply by to make this top y be the same as the bottom, or the opposite, same number, opposite sign? 2? We good? So do that, add them up, and you'll see something crazy happens, huh? Right, we get 10x minus 8y is 6. The bottom one, I'm just bringing the bottom one down, haven't changed it at all. And then you add them up, and look at that. Cancel, cancel, cancel. 0 plus 0 is 0. Well, yes, 0 plus 0 is 0. Thank you very much. But what does that mean about the answer to this question? What is it?
Many solutions.
Many? Is there an option that says many? Oh, infinitely many.
Yes.
Just many could mean like maybe 3. Infinitely many. Sorry, I don't mean to blast you out there. I know. All right. So well, I can't erase that. There we go. All right. So you're right. It's exactly what it is. So there's two weird things. Let me make note of this one. So when x and y both cancel, that's what's happened, huh? That's what's weird. Both x and y dropped out. We're just trying to get rid of y, but x went as well. What does that mean? Well, if you have 0 plus 0 equals 0, that's infinite solutions. And if you have 0 plus, oops, come on. If you have 0 plus 0 equals a number, that's no solution, because that's not true. If you have a number like 7 or something, 0 plus 0 doesn't equal 7, or 5, or 3, or negative 17, or whatever. If you have 0 plus 0 equals a number, then that's not true. So no truth, no solution. But if it's 0, 0, 0, that's true. There's just no x's or y's. It's infinite solutions. We'll talk about that tomorrow. It's never long. Tomorrow we'll show the graphs. And the infinite solution is actually 2 lines right on top of each other that intersect in an infinite amount of points. And the no solution is parallel lines that don't meet at all. So there's no intersection. The normal case where you get one answer is 2 lines that meet at a point. That's normally what's happening. We'll see that behind the scenes stuff tomorrow when we do graphing. For now, just know, hey, if it's 0, 0, 0 infinite, 0, 0 number, no solution. Right? That's the 2 options they have here. So this one's infinite. Option B, we're done. Does that make sense? When x and y both cancel. On that cheery note, let's take a look at them. So 0.02x plus 0.14y equals negative 0.68, and then 0.3x minus 0.4y is 2.3. Look at all them decimals everywhere. Let's get rid of them. Right? If the problems start with fractions or decimals, get them out of there. That's basically always my plan. So if it starts with fractions or decimals, get them out of there. This one starts with decimals. Let's get the decimals out of there and just make them into normal whole numbers. Okay, so how do I do that? How do you get the decimals out of there? Yeah, multiply by numbers like 10 or 100, right? Because that moves decimals. Basically, however many spots you need to move the decimal, that's how many zeros. You need to move it 2 spots, use 100, which has 2 zeros. You need to only move the decimal 1 spot, use 10, which just has 1 0. So look at that top equation. How many spots? I got to move this decimal. Here, let me actually do it. This decimal needs to go 1, 2. This one 1, 2, 1, 2. So in the top equation, I've got to move all the decimals right 2 places, don't I? So that means multiply through by 100, which has 2 zeros, and that'll move them 2 places. So that top equation will become 2x, 14y, and negative 68. Is that good so far? So far, so good? Are we happy? Thrilled? Now the second equation, how far do the decimals need to move in the second equation? Yeah, only 1 spot. So just multiply by 1 0, multiply through by 10. Just decimal once, once, once. So it becomes 3x, 4y, 23. Now it's much better, right? Now it's just whole numbers. Everybody good with that? Multiply through by 100 or 10 or whatever. You don't have to do the same thing to the 2 equations. I did 100 on the top, 10 on the bottom. You just have to do the same thing to both sides of any one equation, right? Which I did. All right. Now let's take it from there. How about we do the y's? Got to make the y's become the same number. One positive, one negative, the same number. So give it a go. So I'm going to multiply the top equation by, well, what'd you guys do? Did you guys multiply by 4? Yeah, you think about 28? If you notice 28, that's better than what I'm going to do. But I'm afraid not everybody would see that, so I'm just going to do it this way, I guess, right? Yeah, the easiest thing, it would be if you know your times tables real well, you'll look at 14 and 4 and you go, oh, they're both going to 28. I'm going to make them into 28. That would be easiest. But you got to know your times tables pretty well to recognize that. It's fine if you don't. It's no problem. You can just do what we were doing earlier, which is what? Multiply by the other guy. That'll work fine. You could do the box thing. With 4 and 14, you'd find 28's the common denominator. It's exactly right. It is the box thing. Yeah. That might be more work, though. You do the box and come back. By then, you've kind of wrecked the savings. But, you know, whatever. Any of those ways are fine. I'm just going to keep it simple and just do what we did on the other ones. And that is, remember what I was saying, if you have numbers on both of them, just multiply by the other guy. That will always work fine. That won't be the simplest numbers, but that will always work. Am I making sense on that? So I'm going to multiply the top one by 4, the bottom one by 14. See how I'm just multiplying by the other guy? Right? So now both of them are 4 times 14. Both of them are 56. Right? Okay, good? Take it from there. And what do we have? We have 8x plus 56y is some big number, 240, 272, negative. And then this will be 42x minus 56y, and I don't know, 230 and 92. I can't do that. 330, 322. All right?
Yeah.
It is 322. 322. Thank you. Is that good so far? See how we made the y's opposites? Everybody see how I did that, right? When both the y's have numbers, just multiply by the other number. Right? That's all we say. Now, if you did the 28 thing, that's even better. If you know about that and you did that, that's going to be even easier. You'll have even smaller, nicer numbers to deal with. That's even better. But worst case, you can do this at least, right? You can always multiply by the other number. That'll work. Is that good? Add them up. Y's eliminate. What's that? 50x. Is that 50? Isn't that nice? X is going to be 1, isn't it? So x is 1. We got our hands on 1. That's very reassuring that we're on the right track. A nice clean number like that. X is 1. We've got to be doing it right when you get something like that. X is 1. So now plug in to find y. Now, when you go to plug in, I'm not going to plug in back in those decimals. I mean, you could, but that'd be a mess. I'm probably going to just plug into this guy right here. The first one that I got, after the decimals were gone. You with me? So I need some space, so I'm going to come up here and finish my work up here. So 2x plus 14y is negative 68. Take that x equals 1. Plug in x is 1 right there. So 2 times 1 plus 14y is negative 68. Subtract 2 from both sides. 14y is minus 70. Divide by 14. Y is minus 5. So x is 1, y is minus 5. X is 1, y is minus 5. We got it. Is that good? You okay? So if you got decimals, multiply through by 100 or 10 or whatever. The rest is pretty much the same. If you have y's, just multiply by the other number. Make them the same. One positive, one negative, opposites. Is that good? Are you ready for the awful, awful, awful one? So, a half x plus a fourth y is 2/3. 2/3 x minus 3/5 y is 1/5. Yeah, there we go. Okay, fractions. So what are we going to do with fractions?
Common denominator.
Call the hit man and kill him, right? Get him out of there. Get rid. That's what we always do with fractions, right? Just like we got rid of decimals with 10 and 100, we're going to get rid of fractions. Yeah, and what we'll do, it's common denominator. Exactly. So what's the common denominator? We're going to get two different common denominators. One for the top equation, different one for the bottom equation. So 2, 4, and 3. What do 2, 4, and 3 all go into? 12. Yeah, if you're not sure, do the box thing. 2, 4, 3. 2 goes into 2 one time. 2 goes into 4 two times. 2 doesn't go into 3. Bring it down. What goes into 1, 2, and 3? Nothing. So multiply these guys together. 2 times 1 times 2 is 4 times 3 is 12. But you probably already knew. 12. 12 is the number that 2, 4, and 3 all go into, right? Okay. So what do I do with that 12? Multiply through by 12. Like that. Is that good to there? And then cross cancel. 2 into 12, 6 times. I'll bring it over here. 6x plus 4 into 12 3 times, 3y. 3 into 12 4 times, and 2 times 4 is 8. Everybody good with that first line? good there? Right, everybody tracking with me in there? Now, what do you do for the bottom equation? What are you going to multiply through by?
15.
Yeah, because 3 and 5, right? The bottom has 3 and 5. So multiply the bottom by 15. And that'll eliminate the fractions in the bottom equation. We good there? So cross cancel, multiply what's left over. Three goes into 15. 5 times. 2 times 5 is 10x. Is that okay? See what happened there? 3 went into 15 5 times, and then the leftovers multiply, right? 2 times 5 is 10x. Right? You cross cancel and multiply the leftovers, right? 5 goes into 15 3 times. 3 times 3 is minus 9y. And 5 goes into 15 3 times. 1 times 3 is 3. Much nicer now. No more fractions. We good with that? So if you've got fractions, get them out of there. Kill them. LCD, Hitman, take them out. Like usual. Huh? Now, we got to go from here. Are ready to go forward now? We're never going back to that stuff. Let's go forward now. All right, take the next step. Any questions on that step? Is that good? Feel free to speak up. I was always asking my math teacher questions, my math teachers. You guys don't have any questions? It's all good. I made them earn their money. I was hunting them down in the halls, asking them questions in the classroom. All right, make those wise opposites. Make those wise opposites. So what are we going to multiply the top equation by? Just positive 3. Because, yeah, they've already got the sign, so just positive 3, right? Everybody good with that? Positive 3. Regular 3. Like that. Everybody see, if I did a negative 3, then that would make it negative 9y, which the other one's already negative 9y. I want to make one positive, one negative, so I'll keep it that way. Is that good? That'll do it, right? So take it from there. Now you're going to get an awful fraction answer. And you don't want to plug that in, so hold on. Let's don't plug that in. By the way, as I go, I'm going to do a new trick here. I got one more trick in this one. I'm going to show you. Let me preempt it right now. Probably help if I say it right now. Right now, I'm going to make the y's be opposites. Well, I better just do it. And then let me say something about it. So it's at 24, and the bottom one is no change. Okay, so I made the y's opposite. Boom, they're gone. Which means I'm about to get an answer for x, right? Because it's going to be 28x, and this is 27, and, divide, it's going to be 27 28. It's awful. But that's right. That is the answer for x. But why did I get x first? I'm about to. Let me finish. So 28x, we'll bring it over here. 28x is 27, divide by 28. There it is. X is awfully... It's 27 28. That's weird and yucky. 27 28. So, why did I get x first? What made that happen? Why did I get x first? Well, because I made y eliminate. right? I made y's be the same number, one positive, one negative, so they went away, and I got x. So could I have back here made the x, instead of doing the y's and making them both 9, could I have made those x's both be the same, make them both 60? Multiply the 6 by 10, you actually could make them 30, that'd be even easier, but you might not notice that. So make this one 60, you make them both 60, one of them a negative 60, and the x's would eliminate, right? And then you would have got y first. Well, let's just do that now. Let's go back to here. Why? Because I don't want to plug that in. Right, you with me? Normally when we get our first answer, whatever it is, we then plug that in to get our second answer, right? But we don't want to plug that in. I mean, you could if you're good with fractions. Got your calculators, it'll do the fractions. Yeah, feel free. But it's going to be easier for most people to just do a restart and get the x's, go back to here again, and get the x's to drop out instead of the y's. Make the x's both 60, one a negative 60, one a positive 60, and then you'll get y and you'll never have to touch a fraction. Does that make sense? We didn't do that on any of the, that's why I say this problem is awful, awful, awful. It was awful in the beginning, it's awful here at the end. Why didn't I do that any other time? Because my first answers were always nice, right? They were nice whole numbers, like x is 3 or negative 2 or something. It wasn't 27/28. That's ugly. I don't want to plug that in. Does that make sense? So if you get it, so let me write that out. When the first answer is an ugly fraction, instead, don't plug in. Instead of plugging it in, restart and cancel the other letter. That'll be easier. So when the first answer is an ugly fraction, can you read my chicken scratch up there? When the first answer is an ugly fraction, I remember I got reviewed. I get reviewed once every 3 years. I got reviewed last semester, and a lot of students said a lot of nice things. I mean, you read them after the semester's over, the things they write. A lot of students said a lot of nice things. One student said his writing it looks like a child. And, I was greatly offended. No, I thought it was kind of funny and kind of true. So let me know if you can't read anything. I'm fine with the fact that I write it like a child, and I'll clear up whatever you can't read. Can you read that? When first answer is an ugly fraction, instead of plugging it in, restart and cancel the other letter. So let's go back and restart and cancel the other letter. So going back to here. So we got x. It's an ugly fraction. Don't want to plug that in. So restart back to here. I mean, I'm not going back to those fractions. I'm never going back there. I don't mean that, right? But right here after we got rid of the fractions, you know. Go right to there. So 6x plus 3y is 8. I'm going to write it down. 6x plus 3y is 8. And 10x minus 9y is 3. 10x minus 9y is 3. Okay. So, and so we want to, this time, get the x's to be opposites instead of the y's, right? So I can make them both 60 like we were saying. So let's just do the top one. You got to make one of them negative, huh? Because right now they're both positive. It doesn't really matter which one. Like I'll do the top one, say, make him negative. Negative 10, negative 10, negative 10, like that. The bottom one's 6, 6, 6. Everybody see what's happening there? Then it'll be negative 60x, and then what's that going to be? Minus 30y and minus 80. And the bottom equation will be positive 60x. What's that? See how the x's will drop out now? See how we made the x's opposites? Same number, both are 60, one negative, one positive. So this time we're getting the x's to drop out instead of the y's. So add them up, bye-bye x's, there they go, off into the distance, into the sunset. And we got minus 84y is minus 72, right? No, 62, huh? 62. Right, 72, yeah. So bring that up here. Minus 84y. This problem is really going to end here in just a second. We're almost done with it finally. Last step. X is won't be alone. Y is won't be alone. Divided by minus 84. y equals, reduces, divide top and bottom by 2, get rid of the negatives, 2 negatives, make a positive, 31/42. There we go. So what's the final answer? Something awful. X was 27/28. X and Y was 31/40. There's X, Y, how terrible. There it is. That is question number, what was that? 14? Yeah, 14. This is question number 14. So that's the worst one in the homework by far. By a long shot. Is that okay? A lot of new wrinkles in that. So in the beginning, it started with fractions. And we got rid of the fractions by calling the hitman LCD, top and bottom, got rid of the fractions. And then we just did our normal thing. We made the y's opposites, got x, but it was an awful fraction thing. We thought, we don't want to plug that in. So let's instead restart. So then we restarted back to the 6x, 3y, and all that. And we said, now let's make the x's opposites instead of the y's. Made the x's both 61 negative, 1 positive. We got our other answer. So we really kind of avoided fractions all the way, didn't we? Even though it started with fractions, ended with fractions, we never did a lot with fractions. We just kept eliminating them and avoiding them. That's my theory. That's my algebra style, is avoid fractions at all costs, basically, whenever you can. Are we good with that? Questions on that? All right, let's take a break, huh?